15 cat owners out of the total number of people, 15, 30, correct. Probability of a dog, Nate? 12 over 30, there's 12 in the dog circle, that's the 5 plus the 7. Probability, what's this symbol, Grace? And, so what's the probability of owning a cat and a dog? No. We shouldn't have a different denominator here. We haven't limited it. We haven't said given at all. So it should just be 5 over 30. How about the probability of owning a cat or a dog, Kirsten? Where's 27 coming from? These two? But you have to subtract the probability of both. 22. Or you could just look at your Venn diagram and just add up. Do these people own a cat or a dog? Yes, yes, and yes. So that would be 22 over 30. What's the probability that you do not own a cat and you do not own a dog? Andrew? What'd you say? Yes. Good job. Probability of owning a dog and not owning a cat. John? Owning a dog and not a cat. Very good. That, in other words, is a dog only. That symbol. How about a cat and not a dog, McKenna? 10 out of 30. And then here we go with the given probability. Take a minute, everybody. Try to come up with a probability of owning a cat given that you own a dog. I'm going to go with Kaylee M. 5 out of 7. Raise your hand if you agree with her. Only a couple. Or you don't? You agree with her? So Maggie and Bo. Why do I keep wanting to call you Connor today? I'm sorry, you're incorrect. It's not right. Your denominator should be what? The dog circle. Not dog only, but the entire dog circle, 12. So out of those 12, now you're looking for the probability of owning a cat. Or in other words, you could say how many are in the both category? 5 out of 12. Raise your hand if you had that. Better. Good. Okay. Do the other one now. Kaylee Smith, what'd you put? 5 over 15. Raise your hand if you agree with 5 over 15. Good. Okay, so out of your cats, there's 15 of those. Chances of also owning a dog, 5 out of 15. Okay. Now, in Part J, when you're asked about independence, which two probabilities from above can you compare? There's a couple different ways of doing this. Andrew, give me one combo. Right, so A and H. Yes? So in A, the probability of a cat is 15 out of 30 versus the probability of owning a cat, given that you're a dog owner, is only 5 out of 12. So the first one is 0.5, just owning a cat. But given that you own a dog, your probability of owning a cat drops to only 42%. Yes? So something about owning a dog made you less likely to own a cat. So are they independent? No, they're not equal, so they're not independent. What else could you have compared? There's another way of doing it. Nate. B and I, the probability of a dog alone and the probability of a dog given a cat. So B and I. So that's 12 out of 30 versus 5 out of 15. So the probability of owning a dog, 40%. Probability of owning a dog if we already know you own a cat, dropped. Nathan. Yeah. Okay. Now, this is another thing, too. Explain the difference between the meaning of this one and this one. Because a lot of people were under the impression, it seemed on the test, that they were the same thing, and they are not. So who can explain the difference? Go ahead, Maggie. Correct. This right here is actually the numerator of this one, right? This is the probability of owning both. So this is just going to give you your number of people that own both. This is your chances, so the chances of owning both versus the chances of owning a cat if we already know you own a dog, okay? So Lydia, you have 2 homework assignments. You have a spiral and then corrections that I'm giving back to you. You decide when and if you're going to show up Thursday, Friday, or Monday after school to take the probability retake. And here, so I may have to talk to you about another option, but